Merging with simulator in 3, 2, 1.
We're back. Okay, here we go. So let's talk about heat input. Now, although plasma seems to create a lot of heat and light, the actual energy or the heat input or heat is less with plasma than most others. The very high temperature of the plasma, it allows for faster travel speeds, so the amount of heat is spread over a larger area. Now, this affects the joules per inch of heat. Now, that the cut will receive. Okay, so there's a lot of math here, but ultimately it's saying we're focusing in an area and we're able to go faster, which means less heat overall. Okay, so distortion. Now, distortion is not your friend. Now, anytime metal is heated in one spot, it can shrink or distort or expand. Now, when the metal cools, and it's not straight, okay? It's not flat, it's none of that. Now, so in order to reduce distortion in oxy-fuel welding, we preheat the plate to reduce the heat affected zone of the cut. Now, this can also affect the cost of the fabrication because now you have to preheat, and that's fuel, and that's the time, and all of that. Now, with plasma, cuts can be made without preheating. Now, this can be a big cost saving though, but keep in mind, the initial cost for plasma, it can be considerably more than with an oxy-fuel system. And oxy-fuel doesn't require any electricity to power it. So, you know, there's a trade-off here and there. Okay, applications. Now, there are a variation of the plasma cutting process. Now, there's a couple of different ones. Now, the first one's called dual gas plasma cutting. Now, dual means two, gas, of course, two different gases. So, one creates the plasma arc, and the other is used as a shielding gas, okay? By adding this shielding gas to the cut, it makes a super clean cut, and it's free from oxides and nitrides. Now, the other is water-injected plasma cutting. I'm pretty sure some of you have seen it or watched videos on it. Now, this is a concentrated column of water that surrounds the plasma column. Now, the water helps the plasma stream concentrate, giving a higher density arc, and it increases the temperature for faster mechanized cutting. So you'll see this with like CNC types of water jets and stuff like that. Now, here's some more variations of plasma cutting. Water shielded plasma cutting. This is where the torch is used to cool the torch. I should say the torch is used to torch. Where water is used to cool the torch, it reduces the sound and the reflected light. Now, this process uses a higher water flow than does water ejection. This is also a mechanized process. Now, precision plasma cutting is a mechanized process that uses thinner materials at a slower cutting speed, but it's made for extremely accurate cuts on mission-critical parts. Pretty cool, right? Cutting speed. Okay, what do they mean by cutting speed? Now, cutting speed is another word for travel speed. How fast can you move to make a cut? Now, most manufacturers will give you a chart like this on particular metals. Now, this chart shows, just for mild steel, it shows how much amperage and voltage that are required and how fast you can travel. Now, when we see IPM, that's inches per minute. Okay, so on a quarter inch, right, we can go 135 inches per minute, maximum at 208. Now, there's a calculation to figure it out. Now, if you'd like me to make a video on different calculations like heat input or travel speed, let me know, leave me a comment, okay? Now, be sure you know what you're cutting. If you're not familiar with it, find out, because some metals give off a poisonous fume and they require fume collection not only to protect you, but to avoid polluting the air. All right, so what can we cut with PAC? A ton of stuff. Any material that can be electrically conductive can also be cut using PAC. Now, there are also a few materials that can be cut that are non-conductive when they coat them with a material to conduct electricity, so they can be cut. Pretty cool, right? Kerf. What is kerf? Kerf is the width of material that is removed by a cutting process. Regardless of the cutting process, there are kerfs. Oxy-fuel, plasma, all sorts of different things. When you cut with a saw or a blade or a grinding disc, okay? Or I should say a cutting disc. Now with plasma cutting, there are some factors that can change the width of the kerf. The first is the standoff distance. This is like arc length, okay? A larger or smaller orifice diameter or the hole of the plasma comes out, the electrode and the nozzle affects kerf size. Just as much as amperage will also affect the thickness of the kerf. So how fast or slow or the travel speed affects the kerf as well. Different gases affect the cut. On average, you won't deal with the direction of the plasma swirling or whether or not you'll use water injection, but we can see that it affects that as well. And we can see the chart gives you an idea to the size of kerf depending on the thickness of the material. Remember, we want to remember rule number 3 and the amperage recommended. So what is rule number 3? Well, thickness of material is going to dictate a lot of information. So if I'm using 18 gauge, I can use 45 amps, right? And my estimated kerf is 0.054. That's a pretty thin kerf. Okay, now the torch standoff distance from the nozzle tip to the work. This is like arc length. But we need to remember that the nozzle tip is inside the nozzle. So here it is. See, here's my nozzle tip. Okay, now this is important in order to get good plasma cuts. Now the kerf is the width of the material that's being removed by a cutting process. Now the kerf angle is used to describe how square your cut is going to be. Okay, now this is the angle that is made from the difference in widths between the top and the bottom of the cut. And angular deflection also refers to the squareness of the cut, but there's a lot of science, so just know that it refers to the squareness of how much we can get it, okay? So like if we're not straight up and down, so we can see this is a straight up and down, if we're just a little bit to one edge or the other, it can affect it. So let me see, I think I have it here. So when I made this video, I did a little research, and there are actually a lot of scientific papers about this exact thing. So having a short torch standoff is important. The distance of the standoff affects the squareness of the cut. So your arc length ultimately affects the squareness. So we can see on the top picture here, okay, this is short. Now it gives us, here's our squarish cut, right? Now, when we start to make longer standoffs, see how it starts to wobble? And it gives us a whole bunch round when we start, as it gets a little longer. So we want to keep it as short as we can. All right, so the most common gas to be used by plasma is compressed air. Other types of gases can be used. Nitrogen, oxygen, argon, and hydrogen can be used depending on the type of material cutting and whether we're using like a mechanized process or not. Now, using a gas can also have changes to the force of the plasma, where the plasma is focused, how much heat is being input, how big your kerf is, and how much dross is, and how square the cut will be. So we can see that it can affect all of these different things.
Please like and subscribe. If there is something you would like to learn about, please leave it in the comments.
Weld the world.